Hello everybody, today I'm gonna to explain question 967. This question is given to me from our calculus course, and now I'm gonna to explain this question to you. Let's get started. In here we have a function y equal x plus sin x, and they ask to find some things, and I show some of them in board. Let's start. First of all, I have to find domain of this function. Domain of this function is from minus infinity to plus infinity. Why? Because we have sum of two functions. One of them is linear function, one of them trigonometric function, and this both of R is both of yes R is both of R defined for all real numbers. Therefore, their sum also are defined for real numbers, and as a result, we can express our result as a minus infinity to plus infinity. Then we have to find discontinuities discontinuities of this function, and I wrote there DHT. What's the meaning of DHT? Doesn't have discontinuities. Why? Because in there also we have continuities, not discontinuities, because both of function both of are also defined for all numbers. Therefore, both of and we saw that there some of this function are defined for all numbers. Therefore, we have continuities, not discontinuities. Then I have to find external points of this function. In there, we have to find derivative of this function, and I wrote the x plus sin x, derivative of x plus sin x, and it is equal to 1 plus cosine x. And when we find external points, we have to first, after finding first derivative, we have to equal this result to 0. And I equal cosine x, 1 plus cosine x to 0, and I get cosine x equal minus 1, and we know from school mathematics it's and from here x equal pi plus 2 pi k. And we see, and then we have to find second derivative of this function, and first derivative of this function is 1 plus cosine x, but the second derivative of this function, I wrote there 1 plus cosine x, derivative of 1 plus cosine x equal minus sine x, because the derivative of constant is 0, but cosine x, derivative of cosine x is minus x. Therefore, we got minus sine x. And I wrote the rule to both. If our second derivative greater than 0, it's increasing and we have local minimum. And if our second derivative lower than 0, it's decreasing. It means decreasing function, and in that case we have local maxima. So we see that we have minus sign in here. So we have to make a connection this rule with this result. So we see that our second derivative is minus. So we use this rule, and we have local maximum, and I wrote there, we have local maximum. So firstly, we have to find asymptotes. I wrote there we have 3 asymptotes. One of them vertical asymptote, one of them horizontal, one of them oblique asymptote. Let's start with horizontal asymptote. If we want to find our horizontal asymptote, firstly we have to find this limit. Limit x approach both of them plus minus infinity, and our function is x plus sine x. And also is x plus limit of x plus sine x equal plus minus infinity, and we doesn't have horizontal asymptote. So I say that we doesn't have vertical asymptote because in our function we see that x plus sine x, and it's continuous function. So we see that if this function is continuous, and it means it doesn't mean it doesn't mean this function is undefined. Therefore, this function is defined. Therefore, it doesn't have any vertical asymptote. If we talk about oblique asymptote, since the function approaches both positive and negative infinity, as a result we get plus minus infinity. So we see this function is defined for all real numbers, and it doesn't have any oblique asymptote, or also it doesn't have any horizontal asymptote. In this question, generally we don't have any asymptote. So now I want to talk about other things that is given to me for explaining. Now I will clean the board. I came back, I cleaned the board, and I wrote some things. Let's continue. And in there, they ask to find the direction of concavity, and for finding the direction of concavity, firstly we have to find our derivative, and we found, and also we have to find our second derivative, and we found both of them. First derivative is 1 plus cosine x, the second derivative is minus sine x. And if the second derivative greater than 0, it means the graph concave up. If the second derivative is lower than 0, it means concave down. And we see in here our second derivative is minus sine x, and minus sine x is greater than 0. In here we mentioned, and if it's greater than 0, it means also we know this from school mathematics. It means 2 pi k, from 2 pi k to in here I factorized this formula, and I get 2 chi plus 1 in parentheses multiplied pi. If minus sine x lower than 0, it means concave down, and also we get from 2k minus 1 in parentheses multiplied p to 2 pi k. I finished the direction of concavity. Also in there I forgot to write, they asked to find the increase, this function increasing or decreasing. In here you have to mention increasing or increasing. No, it's in here increasing. In here, sorry, decreasing. Decreasing. If our first derivative is lower than 0, and we get cosine x lower than minus 1, and we see our result. I don't want to read this result, you see, because when I read this formula, it's just time wastage. If we find increasing of this function, 1 plus cosine x is our derivative, first derivative, greater than 0, and from here cosine x greater than -1, and we see our result. That's not that is. Also, we have one part that they ask to find. Now I am still cleaning the board. I don't know, it's good or bad. It's okay, I think. Now the last thing that they ask from me is points of inflection. Yes, points of inflection. Now I am explaining. But after I finish my explaining, I will show the graph to you. But unfortunately I don't draw the graph to the board because my handwriting is so bad. So I want to show the graph on smartboard, but we don't make a connection. I don't make connection with smartboard. So unfortunately, sorry, I will show in my laptop to you. Now start. Sorry. Y equal x plus sine x is our function, and we see they ask to find our points of inflection. Yes, the points, the second derivative changes sine at sine x is equal 0, and it gives this answer to us. So in there, this interval is between concave up and concave down. So as a result, we get our answer as a pi k, and it is our points of inflection of this graph. So thank you for your attention. But now I will show the graph to you for just 10 or 15 seconds. Now in here you see it's GeoGebra, and it's a very useful platform for everyone who are interested in calculus or math. They can use, and it's very helpful. We see in here our function is x plus sine x, and we see our graph. If we zoom it, we can get as a result this one. You see, this is our graph of function. So I finished my explanation today. I know I talk a lot, but thanks for your attention. That's it for today.